primer about Cohere. We are a full-stack secure enterprise AI company. We're led by our co-founder and CEO, Aidan Gomez, who was one of the authors of the seminal Attention is All You Need paper. At the heart of our offerings are our generative models. Our flagship model is our Command A model, which is one of the best-in-class models in its size and category. On the search side, we have our embedding and re-rank models. These consistently are SOTA in the industry. And then we have Compass, which is a packaged offering that allows you to securely ingest all of your enterprise data, deal with all of the ugliness that comes with parsing, chunking, and knowledge preparation for any of your tasks. And then we have North, which is our low-code agentic platform. The key is all of these systems can be securely deployed either on-premise or in your VPC environments. We are one of the only model providers that is integrated with every single large cloud provider over there. And further, we also let you customize these models either with continuation pre-training or post-training of the models with your enterprise-specific data. Cool. So 2025 stands as a pivotal moment for AI agents. It's a convergence point where possibility is meeting practical reality when it comes to AI agents. What we are experiencing is an unprecedented acceleration in AI capabilities that is creating the foundation for truly autonomous systems. Reasoning models have now crossed critical thresholds, developing the ability to plan, evaluate, and adapt in ways that mirror human cognition, but also exceed certain human limitations. The strategic shift towards test-time compute is enabling these models to think more deeply before acting, which is dramatically reducing error rates in complex tasks. Meanwhile, engineering innovations mean that these models can now be deployed beyond some of the largest tech giants. What makes this moment genuinely exciting isn't that it's not just a technical innovation, right? It's also the ability to transform how we work, moving from reactive systems to proactive systems that can collaborate with humans. So before we dive into the challenges with these AI systems, I'd like to take a moment to talk about what we mean by agents. So up there, I put a few different definitions that I've seen some of the thought leaders and industry leaders define as what an agent is. The one that resonates most at its simplest for me is agents are systems where you're observing an environment and taking an action on that environment. All of those other ideas are not really divergent, but they're building on that same core principle and are various architectural patterns that can lead you to the outcome of an autonomous system over there. Before we jump into, with both our feet with excitement about building agents, I always like to take a step back and recognize one crucial truth over here, that agents are not a solution for every AI implementation. In fact, many of the business problems are better served with something simpler, more predictable approaches. And it's important to look at the evolution of how we got here, right? So at the L1 phase, we had direct LLM interactions, single-turn queries. Then we had enhanced outputs or like RAG-style workflows. Then we gave our models tools. These are all still very valid approaches and could be giving you immense business impact. So these are not things you should be discarding quickly. So next, the evolution that we're talking about here is really basic agents and advanced agents, right? These are the planning systems that everybody is really excited about. And then you throw in more complex patterns around memory or reasoning improvements and feedback loops, and that gives you the level of autonomy that we all aspire for these agents. But before we start building an agent, I guess the primary question I like to ask is, does the task really need autonomy and exploration? Would a simpler approach be more reliable and cost-effective? Because sometimes the most impressive solution is not the most practical one, and the best AI implementations match the right level of capability to the specific business need. So just remember that task complexity, the value, critical capabilities of the models are important factors to consider before you start building these agents. I'd love to dig into the enterprise-specific challenges. So when we're deploying these agents in enterprise environments, we're rarely asking them to perform simple one-step tasks. Instead, what we're expecting them to do is execute on complex workflows that might involve querying databases, analyzing the results, making critical decisions, and then taking actions with multiple systems with these decision points. So this graph illustrates why enterprise-grade agents face a fundamental reliability challenge. Even with a seemingly impressive 99% per step accuracy, after 20 steps with an agent, you're seeing an 18% failure rate. Now with 95% accuracy, which might sound acceptable in isolation, we're looking at nearly 2/3 of all execution attempts failing. And that is really dangerous in a business setting and has real consequences. So the implications are clear. We need to solve 3 problems. 1 is we need to minimize the number of independent failures. 2, we need these systems to be able to evaluate, iterate, and verify themselves. And 3, we need to prevent cascading failures. The curse of complexity isn't a theoretical concern. It is a mathematical reality that defines the limits of what is possible with these systems, and hence it's important for us to ensure our architectural practices account for these. So let's take an example of a simple agent. Let's say this is an analytics agent that you've deployed in an e-commerce company. And you ask it a question, which is, find me the product categories that are underperforming compared to the last quarter and identify the potential reasons for decline. This seems like a fairly standard enterprise use case. And let's walk through how an agent might go through this. So step 1 is intent translation, right? So you need to convert that question into something that really makes sense. And this is where you could see your first potential failure, right? What does underperforming even mean? Is it the number of units sold, or is it the actual revenue decline? If your product experience and architecture doesn't account for these cross-questioning style of iterations, then you could be really looking at those cascading failures. Step 2 is the data retrieval, right? So I pulled out a sample query based on a schema. I gave the model over here. And the challenge is it doesn't really understand all of the nuances about the joins that are involved over here. And it could be excluding certain product categories because of the inner joins it's making in this query. Similarly, when it comes to the analytics query construction, it is taking an inaccurate aggregation calculation mechanism, averaging out errors that would, again, surface lower downstream. And finally, when you're trying to get your market context, you could be missing key insights around seasonality, and eventually your insight generation would be erroneous. So these are the challenges that we're dealing with. So how do we get around this? So my number 1 tip is just often overlooked, which is start with the largest possible model. This is really a critical defense against the curse of complexity, because large models often have the best reasoning, and even that slight bump from a 98% to 99% in performance improvement means that at the stage of your POC, you would have a more successful outcome. And often what I see customers do is they start with the smaller models, which are going to be more complex to prompt and optimize for things like latency and cost. And don't get me wrong, latency and cost improvements are absolutely super critical, but this is something you should be doing as step 2 by using other architectural patterns like caching or distillation of the models, but that can come once you have a successful build out using the large models. So don't optimize too early in the game. So the next step is on effectively using test time compute, right? So for a lot of these agents, faster is a better mindset doesn't really work, right? We don't often need quick responses. What we need is these agents to think deeply about the problems. So if you use a human analogy over here, comparing a student who rushes to their work in an exam versus one that does the work, verifies, and takes the time to get to the answers, you see a better performance with the latter. And the same applies with these LLMs. So you should ensure that sufficient compute and sufficient test time is given for these models to operate, check their answers, try multiple approaches, question themselves before moving forward. So going back to our SQL example, I took that same prompt, but now used the model in a reasoning mode. And as you could see, it created a reasoning trace that allows it to question a lot of the assumptions it was going through, and hopefully that leads to a better outcome. While this is not still perfect, it is on a better path versus where we were originally at. Tip 3 is to break down the complex task into smaller independent units, right? So looking at our analytics workflow, maybe a different pattern of using sub-components would be better. We would be better off with that one, right? So you could have a data retrieval component over here that allows you to load all of the context around like the table schemas, documentation about the tables, which would give you reliable outputs from the database layer, and that could be an independent sub-component. And similarly, you could have a different analytics component or a market insights component. So splitting out these tasks and minimizing the number of steps the agents have to take or the sub-agents have to take would give you better success outcomes. The fourth one is that context really matters, right? A key insight that a focus area that separates successful agentic implementations from the unsuccessful ones is understanding the fundamental cognitive limits of these like models, right? They don't act like us. So you could have an 8K or like 100K or even a 1 million context, but that is the bounds in which the model is really thinking about things. And more importantly, the model capabilities are also bound by the tools that you're giving it access to. So if it doesn't have access to a particular tool or particular data, no matter how good the reasoning of the model is, you're not going to be able to create magic from there, right? So make sure as you're designing the systems, you're thinking like the model, and you're trying to iterate through the problems in the contextual bounds of the LLM and work through some MVP scenarios over there, and then pick on more complex problems. This will save you a lot of pain points when you're productionizing the system eventually. Which is a segue into the next section on the data and tools challenge, right? As a brief recap, the reason we introduced tools with these models was to give them the ability to call external functions, because the models themselves had fundamental limitations around knowledge cutoff, hallucination, and computational weaknesses. But tools aren't without their own challenges, right? The interface problem with these tools is a classic point of failures. And I'd like to draw an analogy with the microservices world over here, right? This is not something we have not all seen. Poor API definitions in that world often led to hard implementations. And the same holds true for LLMs. If your tool definitions are not accurate or not great, you're not going to be able to allow your agents to succeed. They again, are going to struggle, right? So again, taking a concrete example, I have a task for EBITDA comparison report generation over here, and have a few different example functions and potential failure points. As you can see, some very classic failure points, right? So with your parameters themselves, if the model doesn't understand what kind of formats dates need to be passed in, or if you're getting an ambiguous error code, like in the example number 3, which is just an error code and says an analysis bounds violation, the model's not going to be able to act or do anything further with this information. So it's really important that your responses have actual actionable items for the model. So it's a point to take around redesigning your APIs for these LLMs and not just for yourselves. So that's tip number 1. So explicit contracts and documentation is really, really key. So better tool definitions are going to lead you to better outcomes. Make sure you have detailed open API-like specifications for each tool, clear parameter schemes that leave very little room for ambiguity. Again, your classics around K-short prompting also work over here. The more examples you have in your documentation on how to handle errors, the best ways to pass in parameters, and what those functions do is going to really help your model do better with the tool calls. And again, when it comes to versioning of these models, the more explicit you are with the versioning and the documentation and the changes, it is going to help your model perform better at these tasks. Also, once you have passed this gate of like single tool success criteria, success is with these agentic architectures is not about individual tools, but it's about creating the ecosystem of tool calls for an eventual outcome. So it's important that you're thinking about the architectural patterns over here, right? So using the feedback loop so that agents can query the tools is pretty important. Query rewriting is super critical, I find. I find that to be a useful hack just to make sure that you're bridging the intent gap from human beings to LLMs. And then also always start small, right? Like, I think it's better off to start giving your models 3 to 5 tools and trying to build systems with that versus giving 100 different like APIs that could lead to very confusing outcomes, both from a product perspective and for the LLM. And the tools themselves, again, going back to the microservices analogy, it is best to keep them simple, narrow, with individual outcomes. That way, your models know what tools to call for what functions. This also makes the debuggability of your systems much, much easier. Cool, which leads us to evaluations. Again, evaluation is a classic problem everybody's been dealing with across the entire GenAI adoption cycle. I could fill an entire talk with just evaluation, so I'll just try to break this down into a TLDR in the few minutes that we have over here. So as we are building these agentic systems, obviously, what is most exciting for all of us is the final product outcome, right? But as developers, just testing that final outcome is not going to be sufficient, because even a single-step agentic tool call is going through many, many different things, right? So it's going through the decision of, like, is it relevant to call a function? It's going through the routing process of deciding which tool to call. It's going through the execution of determining the parameters, then the inputs and the outputs, and reasoning and any course corrections. So when you're evaluating your model, it's important that you're evaluating each of these steps, and your test suits cover all of these like failure points, because that will ensure that when you're deploying these systems in production, you're able to have a high level of confidence in the tools and mechanisms that you've like developed. So let's take an example tool call over here, right? So this is a weather app tool. So the query that we're passing in is asking it about the New York weather on a specific date. The model itself has access to 3 different tool calls. You can see the get weather info, weather by coordinates, and get coordinates by city. Well, for us, it's obvious it has to take the get weather info call. So that's like one of the first checks that you need to be making over here is, did it get the right function call? Additionally, we need to make sure that it was able to parse the human query and take that and transform that into a parameter that made sense for this function call. So that's your test number 2. Finally, once you have the return outputs over here, you need to be parsing that back and sending that back to the user. So you need to be able to make sure it's not hallucinating its way somewhere in between, and all of these like transformations are working accurately. So that's sort of like the level of like detail that you should be going into when you're building your evaluation suites and the golden prompts and completions. As a breakdown, how we like to think about this at Cohere is splitting this up into 2 different things. First is building the abstract syntax tree that's without any execution calls, but ensuring that the right definitions have been constructed and the model is doing what it's supposed to be doing in a variety of scenarios. And the second is focusing on the execution results, both of which are pretty important. Cool. So once you're past that, another handy insight, I guess, like we've developed by working with many of our customers is failure mitigation. Of course, as you work through these evaluations, you're going to see a variety of failures. As a rule of thumb, what we found helpful is If you're seeing a low failure rate based off your evaluation suite, like let's say under 10%, probably prompt engineering is your best solution over there to get past those like error rates and don't need to go for more intrusive options. And if you're having a medium failure rate, let's say somewhere in that 10 to 20% range, what we find is having a targeted annotation set and improving the model based off that targeted annotation set is probably your best bet. Versus, like, let's say if you're running into a challenge with even the basics of like identifying like the right tool and the models getting confused between the various API calls and parameter definitions, and you're seeing a very high failure rate, it might be time to create a larger synthetic data set, fine-tune or post-train the model, and use that as an intervention to get a model that would do better on your specific agentic use cases. And as a recap, so the 5 things that I'd like for you to take away from this talk would be, first, is agents are not all you need. Make sure you're using the right technique when it comes to like Gen AI systems for your specific business application and driving impact. Keep it simple when you're trying to design these systems. Don't optimize too early. Data context really matters, and evals are still key. And as a final takeaway, I have a demo for the product North that I was referencing earlier for you guys. So hopefully this works. There. So this is our agentic platform. This is the interface where you, as a user, can open up and define either workflows or access your agents. What's being referenced on the screen over there is an agent that was pre-developed. Or as a user, you could go ahead and develop these agents. The beauty of the system is that you can either have these agents to be privately accessible for you or share it with everybody else in your company. So it creates a collaborative like environment for everybody able to work and share the agents across the teams. So the agent definition itself is a multi-step action that involves giving it a prompt, choosing the right model, and then giving it access to the right tools over here. So over here, what we're doing is building a finance agent. So we have given it a specific prompt. We've chosen a default model, and then we are also connecting it to the tools over here. So tools could either be common tools like Google Drive, things that come out of the box. We have connectors for those. Or could be your classic MCP-style tools that you've developed in-house for your specific applications. For each of these agents, you can choose which tools you're enabling and disabling, even on a per call basis, because you might not need to use every tool every single time. And going back to that principle of keeping it simple and under 3 or 4 tools, you might want to be able to pick and choose what style of like your tools your agent has access for a specific action. So once you've done that, you can set the visibility of your tool, again, private or for the rest of the company, and then create this tool. And in a bit, what we'll see is your finance agent has been created, and we'll try to like query it and ask it some questions and see it perform an action. So it's asking a fairly standard question about like a 10K report, as many of the folks with financial documents would do. And once we've hit the submit button, this agent will show you sort of like the reasoning trace that it goes through to generate the response, and then also the final outcomes with like citation. So going back to the controllability and the product design aspect, one thing that we've tried to make sure over here is you as a user can control the reasoning trace. So it allows you to actually edit. And the inline citation gives you access to the actual document. So what you just saw there was you were able to pop up and open the specific 10K that was referenced. So this gives you a high degree of confidence that the actual data source was backing the output over here. So pause over there. I know I'm almost at time, so thank you so much for your time.